Good afternoon, everyone. I'm Chris Cain, Executive Director at CPWR, the Center for Construction Research and Training, and I'd like to welcome you to our Preventing Falls Through Improved Design webinar. We're joined today by NIOSH and OSHA, our partners in the National Fall Prevention Campaign, as well as representatives from Jacobs and Gilbane, who are going to share their industry experience. And now I'm excited to introduce our panelists. We have Dr. Scott Earnest, Associate Director for Construction in the Office of Construction Safety and Health at NIOSH, Bill Wright, Communications Director here at CPWR, Bob Moser, Manager of Health and Safety by Design at Jacobs, Ralph Bierschwale, Architectural Design Manager and Architect SME at Jacobs, TJ Lyons, Safety Director at Gilbane, and Jose Herrera, Safety and Occupational Health Specialist with the Directorate of Construction at OSHA. Thank you all for taking time out of your schedules today. So now with that, I'll pass it over to Scott to get us started.
Hey, thanks, Chris. It's great to be with everybody today and to talk about prevention through design and falls prevention. I'm going to be providing some background on construction falls, on fall prevention, and the importance of prevention through design. NIOSH has been working on prevention through design for several decades. Also wanted to recognize the leadership of our NORA Construction Sector Council Falls Work Group, Rich Trahan and Cheryl Ambrose, who are leading a lot of efforts on fall prevention. And then also within NIOSH, our Prevention Through Design program, Jonathan Bach and Chris Wendt. NIOSH, OSHA, and CPWR have collaborated with NORA for over a decade on the National Falls Prevention Campaign and Stand Down by helping to raise awareness about the hazards of falls from ladders, scaffolds, and roofs. The campaign and stand down is a nationwide effort to reduce the number of deaths and injuries from falls in construction. This year's campaign is occurring May 1st through the 5th. It's an evidence-based campaign, and we also conduct periodic evaluations to evaluate various aspects of the campaign, and we follow an approach that looks at the levels of the hierarchy of controls. Construction workers sustain high numbers of fatalities and injuries. Construction represents about 6% of U.S. workers, but 17% of occupational fatalities, the largest number of all industry sectors. The Falls campaign began in 2012 when the Secretary of Labor, Hilda Solis, gave remarks at an event in Los Angeles. The campaign slogan is "Safety Pays and Falls Cost." The tagline is "Plan ahead, provide the right equipment, and train everyone." This slide shows one of the first posters that we developed for the campaign up in the right-hand corner. We encourage construction employers to join the national campaign to prevent falls in construction and hold their own stand-downs. A safety stand-down is a voluntary event for employers to talk directly to employees about safety. Companies can conduct a safety stand-down by taking a break to have a toolbox talk or another safety activity, such as conducting safety equipment inspections, developing rescue plans, developing job-specific hazards. So why are we focused on falls? This slide shows a number of Focus 4 fatalities by year from 2011 to 2021. This is using BLS CFOI data, and it's a chart that was developed by CPWR. The Focus 4 represents about 60% of all construction fatalities in any given year. Each year, there were between 260, a low of 260, and a high of 401 fatal falls to a lower level in the construction industry. Falls to a lower level are the #1 cause of death. Struck by, electrocutions, and caught in between are also important, but are significantly less in terms of the numbers. Also wanted to briefly mention OSHA's top 10 list of violations. This is the list from 2021. The point I wanted to make that if you look at this list year in and year out, it frequently includes various violations related to construction falls. So like in 2021, the #1 violation was fall protection. Violations of 1926-501. #3, violations related to the use of ladders. 1926, 1053. Fifth violation, scaffolding. Sixth violation, fall protection training. So again, year after year, there continues to be problems within the industry and violations of OSHA standards. Now I wanted to talk a little bit about prevention through design. Prevention through design is a comprehensive approach for addressing safety and health issues by designing out hazards and minimizing residual risk. The prevention through design mission is to prevent occupational injuries, illnesses and fatalities, and exposures by eliminating hazards and minimizing risks to workers in the design and redesign of facilities, work methods, processes, equipment and tools, and products, including new technologies. The aim is to eliminate hazards and control risks to workers at the source, or as early as possible in the life cycle of a workplace. The impact of project planning and design has been found to influence safety on construction sites. Studies of injuries and fatalities suggest that many of the reasons for the incidents that can be traced upstream from the building process itself and are connected to planning, scheduling, and design of the facility. The NIOSH director, Dr. John Howard, said, anticipating and designing out hazards in tools, equipment, processes, materials, structures, and the organization of work is the most effective way to prevent occupational injuries, illnesses, and fatalities. And this is supported by studies. In 1994, Jeffrey and Douglas reviewed construction industry safety performance in the UK and concluded that 35% of the site fatalities reviewed were related to falls and could have been prevented through design decisions. Using OSHA and NIOSH fatality reports from 1990 to 2003, Professor Mike Beam linked design to the fatal injuries in 92 of 224 NIOSH face reports, or roughly 42% of the total. And in a study of the relationship between design and work-related injuries in Australia from 2000 to 2002, Driscoll found that there was either a definite or possible connection to design in 63% of the 43 cases reviewed. This next slide the next several slides provide some examples. This is a photo taken by a former colleague of mine, Matt Gillen, that shows a worker servicing a rooftop heating, ventilating, and air conditioning system. It's an example of why prevention through design is needed. This worker's on the building edge with a clear fall exposure. From life cycle safety, we know that this equipment needs to be serviced on a regular basis, but there's no access. There's not a stairwell for him to get there. He's using an extension ladder to get up. There's no power supply. An extension cord is used. And again, why is the equipment on the roof's edge? Why isn't it set back further? And then if you look back behind it, there's a skylight. We call this an air trap because the worker must work around all of these hazards. And construction and maintenance workers do this every day. A couple other examples related to prevention through design and equipment. NIOSH worked with the National Asphalt Paving Association and many construction industry partners to address the hazards of asphalt fume exposures during road paving. This slide shows a paver on the left before it had controls, and on the right when it was designed with controls included. This partnership resulted in U.S. industry-wide efforts to design, lab test, and field test and validate engineering control modifications to highway class paving machines to reduce exposures. The industry partners signed a voluntary agreement with OSHA to include these ventilation controls on every U.S. manufactured highway class paver, affecting the whole industry. This is an example of prevention through design using equipment. Another example relates to silica and the use of powered hand tools. OSHA developed Table 1 of the silica standard based upon silica control research. This table provides a list of control options to reduce hazardous silica exposures for 18 different tasks. This is a popular table now and will likely be expanded. These controls are now being implemented across the construction industry. It's another great example of PTD that's resulting in fewer hazardous exposures. PTD considers safety and health in the design of a product, process, or system. During planning and design, the safety and health of those impacted by the design in each downstream life cycle phase is considered. The life cycle starts with concept development and continues through design, construction or manufacturing, operations and maintenance, and eventual disposal. This slide shows the building life cycle. The intent of prevention through design is to eliminate hazards upstream, or on the left-hand side of this chart. That is during the business concept phase or the design phase. Changes added after something's built are more costly and are considered retrofit. I also wanted to mention that prevention through design is not new. Believe it or not, it was actually mentioned in the Bible. Deuteronomy chapter 22:8. It says, when you build a new house, you shall make a parapet for your roof. You may not bring the guilt of blood upon your house, if anyone should fall from it. I think this was written in 1406 BC, obviously a really long time ago. Prevention through design is also widely used in many other countries and has been regulated for 30 years in the United Kingdom. It's also sometimes referred to as safety and design, inherently safe design, construction design management, or design for safety. So what's the motivation for PTD? Well, PTD is consistent with the hierarchy of controls and targets the two highest and most effective levels of the hierarchy. At the top, the most preferred approach is to eliminate the hazard or exposure by designing it out. If this isn't possible, the next approach is to substitute a safer alternative. This is followed by engineering controls to isolate or guard the hazard, and continuing downward. The next is administrative controls, followed by the least preferred, personal protective equipment. Another motivator for me personally is the issue of falls through skylights. NIOSH published an alert 30 years ago on this problem, and it remains a problem to this day, and it's preventable. When the alert was published, there were 8 fatalities from falls through skylights in just a period of a couple years. With that, I'll go ahead and turn things over to Bill Wright, Communication Director at CPWR. Bill?
Thank you, Scott. Scott's laid out really well why CPWR is interested in PTD and why it fits so well with our mission of preventing injuries, illnesses, and fatalities. And given what he's laid out, you can see the benefits of PTD. And we were curious, what's the state of PTD knowledge in the field? How are people using it? And what are the barriers to broader adoption, since it is such an effective way of keeping workers safe on the job? And to investigate that, we did some research about a year and a half ago. There were really 2 parts to it. One was a quantitative survey we did with our colleagues at Dodge Data Analytics. They have a really good pool of pre-construction professionals, architects and engineers. And so we designed a survey to ask them some questions about PTD. And then to complement that, we did interviews at CPWR, and those were really led by my colleagues, Babak Momarian and Sarah Brooks, to go into more detail to see what kind of enrichment we could get out of the quantitative study through these qualitative interviews. First thing we wanted to know is, how do people understand PTD? Or maybe put a different way, as you can see at the top of this slide, do people understand PTD? And you'll see that the circle on the left, the pie chart on the left, says awareness of all respondents. What we did was we read a definition of PTD from NIOSH, very similar to the one that Scott read a few minutes ago from Dr. Howard. And when we read that and to the pre-construction professionals, and when you see numbers in this presentation that I'm doing, those all come from the quantitative survey, you'll see that only about a third of the people were aware of that definition. And there was some variation between what architects, their level of familiarity, and with engineers. And in the interviews, we decided we wanted to know a little bit more. So we actually asked people to define prevention through design. And I'll give you a second to read what they said, to give you a sense of the different approaches or the different concepts people have for this idea. As we were preparing to do this research, we realized that we didn't really want to get hung up on language. In other words, maybe people are using PTD, they just don't refer to it that way, or as safety by design, or some of those other phrases that Scott mentioned a few minutes ago. So we wanted to ask about some specific practices that would count as PTD, but wouldn't necessarily, the people we were surveying might not actually make that connection. So we identified, you can see there's 5 topics, 5 approaches on the left. And we asked, well, do you use these techniques to the engineers and to the architects? And you can see that either sometimes or frequently, several of these are quite often used. And if you're wondering why there's a separate column for engineers, one of the differences we noticed in the responses to the quantitative survey was that in the first topic, the identify opportunities for prefabrication, there wasn't much variation between the architects and the engineers. But in the 4 subsequent choices you can see there was a noticeable difference, that the engineers were more likely to say this is something we try to do when we're creating a building. One of the other questions we asked one of the other pieces of data we got out of this was we compared what people said they did in terms of, do you use PTD? And then we compared that to when we asked them those specific questions, such as those 5 approaches that you saw on the previous slide. You'll see that particularly among architects, there was a big difference between what people said, do you use PTD? But then when you looked at what they were actually doing, the use was much higher, which was an encouraging thing to see, particularly in terms of if we're trying to encourage more use, that people are already adopting some of these methods. One other thing I want to mention, but you'll hear a lot more about this in a couple of minutes, is we did ask some questions in the interviews about what sort of PTD techniques do you use? And falls was the primary one. That showed up more often than anything else. We also got several mentions of prefabrication. So people did have specific answers in the interviews about how they were approaching PTD. Given that PTD can be really effective, we wondered, well, what are the barriers? What are the obstacles to broader adoption? And you can see here that we broke out how architects responded and how engineers responded. And let me just give you a minute to look at these. You'll see that while there's some variation, there's a lot of overlap between the barriers with both groups. And particularly, I'll come back in a minute to talk a little bit about that mention of liability, which is something that people also volunteered in the interviews. Here are some responses we got when we were doing the interviews. What are the obstacles? What are the challenges? Why don't people use PTD more often? And you'll see that from these quotes, they really fall into 3 categories. One, just a lack of knowledge. You'll see there's the 3rd one down, or the 2nd one down, where it says our design manager didn't know what PTD was. Then you'll see something that I'm sure is familiar to everyone in the audience. There's questions of cost. And then, as I mentioned a second ago, there's the concerns about liability. Then we wondered, well, how do you increase PTD use because of its potential benefits to workers across the industry? And you'll see here that these answers vary a little bit between engineers and architects, but there's a lot of overlap again, whether it's trying to get more business or have better business relationships. You can see there insurance incentives, saving cost, things like that. And then again, liability shows up again. Finally, we wanted to know a little bit about what people thought would help encourage PTD use, or what would encourage PTD use. And you'll see here, and I'll just let you read this for a moment, that the answers aren't very surprising given some of the things we've talked about in the last, what we learned from our research that I laid out over the last few minutes. But the theme I think you see is that people really want to know, how is this going to benefit my work, which is understandable. And that can take a bunch of different forms. That concludes my presentation. Happy to answer questions when we get to that part of the webinar, but let me now pass it to Bob.
Thanks a lot, Bill. So I'll introduce myself a little bit. I'm the manager of health and safety by design for Jacobs Engineering. It's my job within Jacobs Engineering to champion safety and design so that we can allow construction to be safer as we go on through our design builds. You heard a lot from Scott and Bill about what exactly safety and design is. Put a little picture here of a parapet, but in this case, that parapet's not high enough, right? So you have a parapet, as Bill and Scott were saying, that is actually quite old of a concept. But in this particular case, it just wasn't designed correctly, right? So those are some of the things that we like to resolve when we're going through our designs. So safety and health and design is more of a state of mind than just a process to follow. It's a way of doing things. It's very important that we think about how we're doing things as we're going through our projects and our jobs. It's applying the principles of prevention to the way that we design for safety, health, and construction, safe use, cleaning and maintenance, safe decommissioning. The concentration here within the talk today is within fall protection, but this applies across the board with a wide variety of potential hazards that one can experience when they're building a building or building a construction project. We look to deliver the best practice design solutions. So sometimes best practices may not actually be in the code, may not actually be required, but the best practice is the way to go, in my opinion, well, as we're progressing through our designs. And we want to give our designers the opportunity to be creative, innovate, and challenge the designs. So that's very important, and also be able to give the designers and the engineers and the architects, give them the tools or make available the tools that they can use to better their designs and make everybody safer down the line as we go into construction. So delighting everyone as a result of the above, right? So we're not going to do the minimal. The minimum is not the way that we want to go. We want to go above minimum. So what this is from Shimbersky, 1997. And what this shows you is this is a graph of the ability to affect safety versus a project's schedule. So if you see up to the left, that's your greatest ability to affect a project or affect safety in a project is in the design. That's when you can affect it. So the more that you're concerned about safety and the more that you do to make sure that you can implement safe practices and best practices early on within a project, the better you are. As you go back down into detailed engineering, procurement, construction, and even into your startup, you start to lose the ability to affect safety and to be able to get safeguards into your designs that will protect personnel later. Like for instance, in the parapet example, designing a proper high enough parapet to protect the personnel that would be working on that roof. And also to be able to get that parapet in at a time and schedule to where you're going to help the construction personnel not be able to fall early on in the project rather than later in the construction. So this I like to show. This is a little picture. I think it was Scott that was showing the hierarchy of controls as we go along and look at the different controls that we implement within our jobs. So in this particular case, this is the concept of design safety. And these are the layers of inherent, passive, active, and procedural controls that reduce the risk in the hierarchy of controls. So this gives a little bit of a visual to say exactly what we want to do as we're doing our designs and as we're progressing. So if we look to the left, you're on solid ground, you have railings, you're very well protected from fall risk when you're on the solid ground and to the left there. That's your inherent protection. So that's, for instance, if you're working on a first floor building without a basement, you're on the slab. That's you're very not prone to fall. You can still trip and fall, but if you're on solid ground, you're much safer. Then we've got your passive, right? Your passive is when you're relying on something to protect you, but that something is very solid. Like in this particular case, we have a structure, right? So our bridge is within a structure. We have fall protection in the railings. So you're protected there with like a passive type of protection. So it's not going to be very prone to failure. So you're not quite as good as in the inherent safety, but the passive safety is pretty good. So for instance, if you're in a building that's already got the shell put on, you're working in a room, you're less prone to a high fall, even if you're up on a high building, right? So the next level is active protection. So in this particular case, you got a helicopter holding up your structure, right? Your bridge. So that means that you're relying upon something active. Like for instance, in this case, it's a helicopter. So you're relying on that helicopter to hold you up. So it's not quite as good as the passive or the inherent, but it's a little bit better than the procedural. Procedural is when you're relying upon yourself or other people to be able to protect you. So a lot of times in fall risk, a lot of the protection is within the procedural realm. Like you have fall protection that you're wearing. You can put that on wrong. You can make a mistake. So that's why procedural controls are not quite as good as the active, the passive, or the inherent. So this is something to think about when you're actually designing, because it allows you to be able to see if you can get it more over to that left side of the inherent type safety. So a lot of times, protection through design and inherent safety and health and safety by design, those are concepts that are wonderful, and we like to be able to do those concepts, but and a lot of people always ask me how. Well, how do you do it? So I can give you some examples within our company of exactly how we make sure that we're designing for safe design down through the construction phases. So the first thing that we do is we put together a health and safety in design plan. So I think everybody is probably very familiar with the health and safety plans when they go into construction, but this is actually early on. This is in design type plan. And then we we conduct what we call hazards or hazard identification reviews. So therefore, we get a lot of talent together, personnel together that are very experienced in doing this type of business, and we brainstorm and we figure out, okay, how can we ensure that this building that we're building is going to be very safe and it's going to be safe to construct. So that's when we start talking about this. That's during our hazard identification process. Then what we do is we conduct systematic constructability reviews. So that includes looking at your documents, your documentation, like your technical specification, your drawings, your bid schedule, because schedule is also very important as it comes. You can have some great features in your building that prevent falls, but if you don't put them in early enough, you may not have those then for protecting someone during the construction phase. And really and truthfully, the whole objective here is to be proactive in design so that the construction is not reactive. I think that's the way to kind of summarize the way that we do design safety, which is we try to be proactive and we try to be innovative, and we don't want to have to react to unsafe conditions later on during the construction phases. So that's my section of the presentation, and I would like to introduce our registered architect. That would be Ralph Bierschwale. So Ralph, if you want to take it.
Thank you, Bob. So Bob and I work at an architectural and engineering office in Conshohocken, Pennsylvania, focused on the life science business. So our projects are primarily based on pharmaceutical manufacturing buildings, which includes warehousing, laboratories, office buildings, and let's say other support buildings like shops and things like that. So commercial construction is what we're typically focused on. And a lot of our clients have a strong safety culture, and we bring our own safety culture to it. So there is often support within our community to continue to advance and improve our safety culture. So, you know, within the company, we talk a lot about design with the end in mind, with the idea that we're thinking about the people who are going to occupy the building and occupy it in a safe manner, be able to maintain it, access things and the like. And, you know, in putting this presentation together, I thought we should also be thinking similarly about designing with construction in mind and how we can make the environment for contractors safer as they're building the facility. So as Bob just mentioned, we make the hazard part of our normal design planning process. And that means that, what does that look like? We use BIM software. It's our 3D modeling software, and either looking at it through a Revit model or through a Navisworks model. And we walk through the building, and when we do that, we can identify ergonomic challenges and improvements. We can find tie-off points. Let's say if we need to enter a large vessel through a manway, but other maintenance activities or construction activities for that matter, we can anticipate where we will need some sort of safety element to actively become part of the project. Those sessions are conducted with the wider team and typically also with the construction manager, ideally. So what I'd like to explore as some examples, you know, brief examples, are exterior elements and some interior elements, and I'll explain as I continue. So, you know, I'll continue beating the parapet, but parapets are important, and there's a lot of ways to prevent falls. You can have railings, you can have tie-offs, but you know, the parapet is the gold standard. And if you look at codes, building codes, they're not uniformly the same. You know, OSHA likes to see 42 inches for a parapet, but you're not always required to design to 42 inches. We do because that's really what you want to do. And if you understand how a roof is designed to allow for drainage to work properly, roofs, even flat roofs, have pitches to them. So the parapet actually needs to be 42 inches, ideally at the high point of the roof. So there's places where the parapet might be considerably higher actually, but at a minimum, it should be 42. And in the design process, it's very easy to lose track of that. You could make it 42 at a low point, and then you would be having a lower parapet in areas where you don't want it. So it's a simple mistake that people make, and I think it's an important one to be wary of. So in general, you know, we would prefer to design with a flat roof. From a constructability perspective, it provides a much more even platform to work from, and it's considerably safer than having sloped roofs. Now, in this image here on the bottom right, it shows a curved roof. You know, it's quite aesthetically appealing. And in the case of this building, which we designed in Singapore, there was a desire to have sloped roofs to shed considerable amounts of water based on how much it rains during the typhoon season there. And we actually had an incident where someone was sliding off the roof and was caught by a large gutter at the edge. And really, the lessons learned was there's better ways to deal with getting rid of water than a sloped roof. We were lucky not to have any injury in that incident, but you know, the next nutritional facility that we designed did not have a sloped roof. We went to flat roofs after that. So, you know, another thing that example that I wanted to bring up, and this doesn't work for every building typology, but for elevated slabs, this may be more in the category of tripping and falling rather than falling from height. But there are significant risks associated with pouring slabs on elevated levels. So metal deck itself, rebars, studs, pouring concrete, dealing with shoring, all of those things, as you can imagine, walking in wet concrete represent falling risks, especially if you're at the building's edge, but even in the middle of the building where these workers are working, for instance. An alternative approach for certain typologies is to use more precast elements. And that was one of the themes that we saw earlier on in the presentation. We see more of this in our European operations. You know, we do work all over the world, and they're more likely to be using concrete elements like the ones that you picture here. They're used often in office buildings, hospitality work, and the like. Less so for manufacturing buildings that we're involved in, but certainly some of those buildings could be done in a more prefabricated way, as is illustrated here. So when we're thinking about cladding, lots of different ideas come to mind. There's a little cartoon at the top there where we were ideating different ways to clad a manufacturing facility that we were designing. And, you know, we don't want to restrict people from coming up with great ideas and having really innovative designs and all of that. But there are methods that can be employed irregardless or regardless, sorry, of the of what that building looks like. And so again, going back to the methodologies of construction, oftentimes we look at using insulated metal panel and curtain wall, and those are often stick built. So you're putting up girts, going floor to floor. There's a lot of work at the building's edge. There's a lot of people in bucket trucks and things like that. Lately, along with our construction managers, we've been working with industry to do larger panelized facade elements that can be delivered on site secured quite quickly and improve both our schedule and our close-in time. So the sooner you get that building closed in, the safer the site's going to be, the less work that you have at the building's edge from both inside and outside. So I think this is becoming quite a common practice, and it certainly is to be encouraged. So a modular stair tower, this came up in a construction review of a project that we're working on currently in North Carolina. And it was an important and clever idea to modularize the exterior stairs and deliver them so that we wouldn't have to have scaffolding on the building's edge prior to the stairs being built on site, stick-built or otherwise. Now, an important thing to take into account here is schedule. Now, this was a really smart idea, but our prefabricator wasn't able to get the stairs there as early as we would have liked. So there was scaffolding and then there was a stair. So it's important to schedule things like the stairs to arrive just as the steel arrives, so that you can have the safest possible way to get to elevated slabs rather than using temporary structures. Along a similar kind of theme with regard to stair towers, we like to include windows in the stair tower itself. Even after you've clad the stair tower, oftentimes it takes a while until permanent lighting is put into the stair tower itself. So temporary lighting can give you lots of weird shadows. Sometimes it's not put in on time. And windows in the stair tower provide an added layer of natural light to help you see where you're going. And if you're in the stair tower, sometimes being able to look out, see what's going on the construction site, if there is an active emergency, to be able to see what's going on outside is a benefit. Now, it's, of course, it adds cost, but it is both aesthetically pleasing and it adds a layer of safety in a number of different ways. So, you know, in this example of a building, you know, we were trying to employ a number of these tactics, including floor-to-floor cladding, windows and stair towers, and prefabricated elements. As you go into the building further, there are some sort of industrial type of details that I wanted to point out. And one is pit-mounted equipment like scales. We encounter quite a number of these in any of our installations to weigh IBCs or other materials that be coming into a warehouse or into a production room. And these can be either pit-mounted, so they're flush with the floor, or they can be placed on a floor and have a small ramp on them. They both have their advantages and disadvantages, but we prefer to put them onto the floor so that the pit itself doesn't become a tripping hazard during construction and a cleaning problem later on in design. It's a similar thing for loading docks where we have dock levelers. The example to the left is a pit-mounted dock leveler. It's nice and smooth when it's done, but during construction, you have this pit at the edge of a building. The door might not be there, the leveler might not be there, and you have an unsafe condition there. And in operation, if the door opens up, you have a 4-foot fall to the outside, whereas the vertical storing leveler that you see on the right, even if the door was open inadvertently, the vertical storing dock leveler would prevent you, and certainly a fork truck, from falling off the loading dock, which is a common problem. And one more topic I wanted to bring up is the use of curbing. It's a very common thing, you know, to put housekeeping pads underneath equipment. In this example, I'm showing HVAC equipment, and you can buy the equipment with curbing, as you see in the drawing or image above, where it's a metal pre-engineered kind of curbing system that comes with the equipment. The one example on the bottom shows a concrete pad, which is poured ahead of time. It's a robust solution, it's cleanable and all that, but it does provide a tripping hazard that we would like to eliminate. Oftentimes you'll see the edge of those curbs painted with yellow lines, and that's an improvement, but it's actually better and simpler to simply put the curbs in with the equipment. And we've been more and more ordering equipment this way to prevent that small amount of extra tripping that can happen after the fact during maintenance operations. So that's it for my presentation. I'm going to pass it on to TJ, and thank you. And I look forward to questions at the end of the session.
Jay, I'm not hearing you. I don't, is that just me or I see that you're unmuted on WebEx. But I don't hear, I don't know if your microphone has a separate mute function.
No, it should be working. Can anybody else hear me?
Oh, now I can hear you.
Yeah, okay. Well, I'll just keep going. I got to catch up anyway. We're kind of be running behind, but I did want to tip of the hat to Christine Branch and Matt Gill and some of the earlier folks that got this going, as well as Donna Heidel. I work for Gilbane, been trying to incorporate and have incorporated a lot of the best practices that we've been finding in prevention through design into the actual projects. I'm going to run through some very quick examples, but if anybody's interested, please reach out to me afterwards and I can give you the details on how they were fabricated, how they were developed, or even some of the vendors. What's very important here, I think, to share real quick is that almost every one of what I call these design interventions results in efficiency and cost and profit. You kind of get safety by default, and people really listen when they can make some money. And some of the things I'm going to show you will certainly increase what we're doing in the workplace while making it safer, which is, that's the perfect recipe. So again, let me just kind of go through some of the examples that we have in the field. We're already seeing these in contracts. My first story, which is a great story, a gentleman came in from this door off a roof and slipped and broke his arm on a smooth concrete floor. This is an elevator room. And I brought the architect up the following day and asked him why that floor was so smooth. He didn't know. He thought maybe it was because it would be easier to sweep, but if you've ever been in an elevator room, they're very rarely swept. And I asked him if we could have put a rough surface on his floor with a berm while the concrete was wet, so you couldn't slip. And he was like, yeah, we could have done that. And in fact, it would have been a whole lot cheaper. A lot of these interventions go back to common sense, common practice. And that's why it's great that we were able to share some of these lessons learned and best practices today. This one came up earlier in the presentation, but it's a bit of an embarrassment, I think, to the industry. Only about 3% of skylights in the U.S. will hold the weight of a person, yet overseas, across the board, pretty much you can hold the weight of a person. We are far behind here in the U.S., and through prevention through design and some of these educational tools that we have, like this presentation, we're getting people up to speed on how we can do this. So again, any examples you're looking for on the better ways to do this, please let me know. But they now make skylights in the United States you can't fall through. And step one to getting ahead of people getting hurt. A couple things that I routinely see in the field, and one of the great fixes, we put in these temporary hole covers for ducting or shafts, etc. And they're very temporary. They fail quite easily because they're poorly fabricated by other contractors. Turner, in particular, on the right-hand side here, are starting insetting the floor in the concrete. So you can actually drop a steel plate in the floor, great capacity, it won't move. It's easy to remove and relocate, and you can use them throughout the building as the floors progress. So some of, again, these interventions are fairly simple, but going back to the earlier conversations, you really do have to be involved in the design phase of a project to make this work. But once the subcontractors and the people putting the building together understand, it's just a great way to do it. It's going to go a whole lot faster, and there's absolutely no maintenance on this compared to a regular hole cover. They'll listen very closely. It's just another example of one on a steel deck. It's put in place. This thing is not going to move. very well thought out. This is planning at its best, and this is also prevention through design at its best. Now you're going to see a few more examples of exactly this. Things we need to start putting in the contracts and the additional provisions, as we used to call them, so the contractors know what's expected versus trying to change their habits halfway during the project. One of my favorite stories, we talked about a slope roof earlier. This is a aircraft hangar on an Air Force base I was working at, and the contractor was very worried about how they were going to fall off the roof, and they went out and they were going to buy about $22,000 worth of fall protection gear. And I said, well, aren't you guys going to point up the building? This is a concrete stone building. Yes, we are. It says, well, if you're putting up scaffold, why don't you just put the scaffold one layer past the rooftop? And it was incredible. We ended up winning an award for this. But again, some of these interventions aren't necessarily things. It's how you put the work together. And prevention through design isn't just something to look at early in a project as far as how the building's going to look. Though I'm a big fan of full parapets, and probably more on that later. But it's actually on how you put the work together. You can really prevent a lot of injuries by just simply looking at how we do the work, because we have to do it differently to kind of win the war. In falls in particular, we're not. But some of these simple interventions where you can't fall off a building and do the work probably 2 or 3 times faster, that's what's going to save some lives in the construction sites here in America. One of the cool things about PTD, and this is again why I enjoy it, again, there's not a lot of cost in many of the things we do to make it safer. I took a photograph on the left-hand side in California. This is an entrance to a hospital. You can see the lady's foot on the left there, very close to tripping, right? Just a classic example. Turner Construction, I'll tip of the hat to them. A guy named Paul Huntley, and this is Yale University, worked with a fencing company. They developed a freestanding fence with all the weights on the inside, completely eliminating the chance to trip over a fence, right? So this is one of the few, but several examples that we can get you for those folks who are listening. Very similar circumstances and cases where this is already happening in the field. And I'll be honest with you, if you had somebody trip over a fence in the United States today and then went to litigation, you would be in a poor position because, as you can see, you could have eliminated this hazard by kind of just designing the work better, buying the right stuff up front, and making sure the contractors knew what was expected, again, versus trying to change this during the project. When I hear, hey, we've always done it this way, I typically listen a lot closer. I mean, this is a really nice ramp. I took this picture in California on a great site. But again, as you get on here, people are going to trip, and it can't push anything with wheels across it, right? This is a good idea at the time, maybe 10 or 15 years ago. But there are some new products that I want to share, new approaches to things that we should be doing on every site. And again, if you put these simple interventions in a contract, a construction project contract, make sure it's bought out by that particular contractor, the carpenter, whoever, you will really find a great advantage in eliminating a lot of the falls, trips on your projects by some of the things I'm going to share here. Very few people are aware of this unless you're on very large projects like a Google or some of the Jacobs jobs, but the material on the right is something called Scudo mat. Now, Scudo looks like a Scotch-Brite pad. You can't slip on it, period. And that's what I love about it. And it comes in sheets or rolls. And the photograph I took on the right, I took in Nashville on a very cold morning. That's frost on the steps. And if that treatment had not been on there, the first person off those steps would have probably fallen, right? There's no reason he wouldn't have. When you put this material on, which is fairly inexpensive compared to a fall, you move from risk management, which is when you put up a sign that says, watch out, slippery steps, to risk elimination, where you eliminate the hazard, something we truly need to spend more time doing in construction. On the left-hand side, if you've ever been on a roof that's made out of this type of fabric in the rain or ice or snow, deadly, right? But if you put a walking surface down like this, 2 things can be accomplished. You can do additional work on the roof, and it's a whole lot safer to get there because you have a very defined way to get there. And we've put things in place to keep people on the roof so they don't put holes on the other side of the roof from their feet, etc. If you're familiar with roofing, nothing worse than having other contractors on there. Again, information on this stuff, please reach out to me. Now on the left-hand side, something we've been doing for years, right? This is stamped metal. You put it on ramps, you put it on steps. Again, there's no way you're going to trip on this step, but if you maintain it, which is important, you can eliminate falls from any of these surfaces. And what I'm advocating, by the way, is across the board, if somebody has slipped on something once, they're going to slip on it again. And when you put it on the right-hand side, like on a ramp at a construction site, this is in New York, and you really have moved along and you're setting the standard for preventing falls by how you design the workplace and in fact, the working surfaces that we ask people to work on. Just two other quick ones here. Very common, but something we don't think about until somebody falls off a flatbed and loading steel or the back of a truck that they're using to store materials on a work site. The ladder on the right actually came from the truck driver. He brought it because, yes, he had fallen off a truck in the past, so he brought his own ladder. They're made in Arizona, if anybody's interested. Something I'm a huge advocate of, coming up with the idea of ladders last, years ago, is getting them off the workplace. On the left-hand side, again, if you're the first guy up in the morning with muddy boots, everybody else going up there has mud on their hands. But these ladders on the right-hand side, either for excavations or getting to upper levels, you can move folks about 2 times faster. You can go up with a lunchbox. They're reusable, recyclable. You can get lead points for them on construction sites. And again, if you can get lead points for something on a construction site and it's safer, it's a win-win for people who are building these buildings and also for the owner. One of the last tips I have, this is too clever, too simple, too easy. I found this in California. When you're walking across rebar mats, you tend to have to watch everywhere you put every step. And what they started doing here is putting down what's called a sidewalk screen, very lightweight screen, so you can walk across the surface. And when I interviewed the folks that were working on this project, they said they were working about twice as fast because they didn't have to watch where we walk. Again, one of the things that we really need to get ahead of is we've always done it this way, and we need to think about how we should be doing the work, especially in the interest of keeping that worker safe from a simple fall. And last, one of my favorite quotes, and this is a project where going to the site, which is about 1/8 of a mile away, we paved it. We paved it so they had a nice, easy way to get there. They're not going to slip on the mud. They're not going to bring mud into the building. It's a simple process. So again, if anybody wants details on this, let me know. And I'm going to pass this off to Jose. Thank you.
Hi, hello. All right. My name is Jose Herrera, and I work with the OSHA office. Just give me a moment. Okay. So yeah, hello, my name is Jose Herrera. I work with the Directorate of Construction at the National Office of the Occupational Safety and Health Administration, and I'll be presenting some resources available on OSHA's website and from our counterparts who have gone through great lengths to draw attention regarding prevention through design. And just a little disclaimer here. This is a disclaimer for the materials being presented. Now, I'll briefly navigate you through OSHA's current prevention through design resources. So to start, here's a view of the current OSHA.gov homepage. Near the top of the page, we have some navigation tabs. Zooming in a little, when hovering over the Topics tab, a drop-down menu will appear. And as you can see, it's categorized by topic and industry sector. Under the second column titled By Sector, you can click on the construction link. And this is the construction industry page that we have. You may have to scroll down a bit, about mid-page. And under the fourth column, named Special Initiatives, there's a link for prevention through design, which brings us to this particular resource page. And zooming in, I highlighted the area with some outside resources related to prevention through design from our partners. And I encourage everyone to visit www.osha.gov to explore the website further. And as you can see, you can also sign up to receive some OSHA information and reach out at www.osha.gov/contact us. OSHA also has a presence on these social media platforms. And now I'll share some resources from our partners. So this slide shows the NIOSH topic page for prevention through design. Starting at this page gets you to a lot of other resources related to prevention through design, as far as mission, approaches, publications, workshops, partnerships, and use. This slide shows the NIOSH Prevention Through Design Award that was started a few years ago. The award's purpose is to bring attention to individuals, teams, businesses, and organizations that have eliminated hazards through design or redesign. This award is presented in partnership with ASSP and NSC. NIOSH developed the Workplace Solutions series as useful job aids to put ideas into practice, such as preventing falls, designing out hazardous noise, and a general guide to demonstrate the business value of prevention through design's hazard control. NIOSH has educational slide decks available also. These can be downloaded for free by anyone. They include many photos and instructor notes. And here are a few examples: architectural design and construction, structural steel design, mechanical, electrical systems, and reinforced concrete design. NIOSH directly contributed to prevention through design chapters, homework problems, and case studies to over a dozen key textbooks. And it's encouraging to know that many more textbooks are including PTD methods and principles. Research establishes the value of adopting PTD interventions, addressing existing design-related challenges, and suggest areas of future research. The research focuses on design factors that effectively reduce occupational injury and illnesses by collecting and analyzing data that assesses the impact of these prevention through design factors, as well as economic and business issues, such as financial analysis of PTD impact on the business process. In the area of policy, having PTD priorities and methods included in government and business policy documents is crucial to building PTD into normal business processes. Happily, there are now dozens of standards around the world that include PTD principles and methods, and some countries legally require early design safety review efforts. I will point out the two key consensus standards. First is the ANSI Z10, titled Occupational Health and Safety Management Systems. The ANSI Z10 includes PTD because controlling hazards through forethought and planning are essential ingredients for an effective management system. A second consensus standard, most importantly, is the ANSI Z590.3, which is titled Prevention Through Design. And now here, this is now a PTD credit toward LEED building certifications being used around the world. And just as a reminder, LEED stands for Leadership in Energy and Environmental Design. And here are the sites for the LEED PTD credits and webinars. NIOSH has partners and colleagues that offer many superb educational resources, such as ASSP's PTD Risk Assessment course, webinars from the U.S. Green Building Council, and a ton of other great resources at this website, such as designforconstructionsafety.org, which is run by Dr. T. Michael Toole, a prevention through design advocate and researcher. Another great source of education and active stimulation toward new ways of thinking is the ongoing PTD workshop initiative that NIOSH is funding with Arizona State University. NIOSH funded 5 workshops over a 5-year period. So far, 3 workshops have occurred with 2 remaining. Another one is being planned for late summer. The past workshops have included a variety of speakers from academia and many industry sectors, providing thought-provoking insights and practical experiences. These workshops have been recorded and are now available on our new YouTube channel shown on this slide. Now, this slide shows a new document from Dr. John Gilbane at Oregon State University that provides a tremendous amount of information on how to undertake prevention through design in the workplace. A project collaboration with Dr. John Gilbane of Oregon State resulted in this design comparison tool at this website, constructionsliderule.org. At this site, you answer the prompts to compare the overall safety profile of different design choices for a facility. CPWR also has a number of free resources and research reports related to prevention through design on their website, which can be accessed for free. In addition to this webinar, which CPWR is hosting today, they have done several webinars on various aspects of prevention through design in the past. These recordings can be found on CPWR's informational webinar series webpage and CPWR's YouTube channel as well. Another very new resource that's available through CPWR comes from the NORA Construction Sector Council's Falls Work Group, creating a fall prevention checklist for architects and design engineers. This was developed by researchers and is still being finalized through an extensive review process. However, an interim version is available to help design professionals consider various design components and their safety impacts as they relate to construction falls. The work group is also working on a checklist version for residential construction. CPWR has assembled planning resources that focus on fall prevention, fall protection, and fall rescue. And those are all available on stopconstructionfalls.com. A full written fall protection and rescue plan template is available in English and Spanish. And for smaller contractors who may not have the capacity to complete such a large document, there are smaller and concise guides available. And finally, we'd like to draw your attention to the fact that CPWR has a number of other hazard-specific planning resources that can be used by employers to think through risk reduction well before construction ever begins. An example is the Best Built Plans program, which includes a planning tool and supplemental resources to help contractors plan to reduce soft tissue injuries from manual materials handling, from the bidding phase all the way through a look back at lessons learned. CPWR also has a silica exposure control planning tool, a COVID-19 exposure control planning tool, and they are releasing a beta version of a planning program to prevent struck by incidents in the coming weeks. And with that, that concludes my presentation, and I'll pass it over to Chris Cain. Thank you.
Thanks, Jose. So we've got a lot of questions that have come in during the chat, plus a ton that came in beforehand. So I know we won't get to all of them, but we will get to a number. I was just sending one more to Aaron to consider. Oh, and I sent it to Christine instead. I'm sorry, Christine. Well, the question was that and this is for the OSHA folks to think about, and if you can find it, we can post in the chat to everybody, a link to the OSHA safety tip of the day. The person said that they're a quick take subscriber, but didn't see the tip of the day today. So that's the question. If you guys can think about it, that would be the one that just came in. So some of the questions that came in beforehand, if folks can come on camera so we can see you as you answer. The first one I'm going to throw at Scott Earnest that came in before. What does fall prevention look like for roofs and roofing with solar panels?
Hey, thanks, Chris. Great question. And it turns out that if you go to CPWR's website, they actually funded 2 small studies on installation of solar panels on houses. One was published in 2017. The other one was published in 2020. The authors for those reports are Lee and Gambates. And if you look through that, it mentions the use of modular solar systems, using simple roof shapes, communicating with the designers on where the solar zone will be located on the roof, and then also eliminating obstructions and tripping hazards near the solar zone. So the couple really nice reports that were written, and anybody interested in PTD and solar panels installation, take a look at those reports.
Oh, great. And like lightning, Jessica found the link to those reports that we have published through our small study program. Thanks, Scott. This one I'm going to throw at TJ. Please give some simple steps for very small contractors to use to be proactive in preventing falls.
We were working up in Montana in the middle of winter, putting up a roof on a border patrol station, and it was just too cold. And the little contractor asked if they could build a roof on the ground and just bring in a crane, and they did. And they put the roof up 40% faster. Prefabrication is probably the key, I think, to success for the smaller businesses. If you can't make it yourself, have somebody else make it for you in modular. And if you start putting houses together like Legos, safer, faster, and more profitable. I think those are the best things to look for. But also look at some of the new tools out there. We've got projects now where nobody sands sheetrock by hand anymore. We're using the device that sands the sheetrock and collects the dust. You should not be cutting unistrut with a saw. Nobody really uses saws, or they shouldn't use hacksaws to cut unistrut. There's a simple device called the Greenlee 30T that shears it so fast, cuts your cutting time down from 56 seconds to 11. So both modular approach, make it fast, and use the devices that are now available, and get rid of the corded tools. We spend so much time worrying about cords when most tools are battery operated. Get rid of the cords.
Great. And that reminds me, and I saw somebody else just pop in the chat to the panelists. You had the images of the ladders to access the truck bed. There was also the anti-slip materials that you highlighted. We'd love to have more information on those at CPWR to integrate into one of our resources. We have a construction solutions database where we try to highlight commercial products that are available for anybody to buy to reduce hazards, and those would be great. I think anybody online would be interested in hearing more about those too. Question that came in during Bob and Ralph's discussion. What were the types of models that you talked about using with the BIM software?
Well, the BIM software that we're typically using is Revit, which is the predominant software in the industry. But sometimes to share those models, we use Navisworks, which is for those who don't have Revit installed on their computers, they can share models through Navisworks.
Okay, great. Over to OSHA. A question came in. This is more of a regulatory question, but is it required to use fall protection while in a scissor lift?
You guys can, oh, there we go. All right.
Yep, we hear you.
Right on. Yeah, with our OSHA regulations, fall protection is not required on a scissor lift. Just because there's really no risk of an ejection hazard or being catapulted out. Um, yeah, yeah. So just to be clear, yeah, fall protection is not required. The employer may, depending on the hazard assessment, may require something like that, but the scissor lift would need to have an approved anchor points on there.
And they're already equipped with guardrails.
Yeah, exactly. There's got you have just they have to be inspected, make sure that the guardrails are good, all the components are serviceable, and of course, just checking the conditions of the tires and ground conditions, make sure everything's nice and stable.
Great. Now these questions came in during, I think it was when Bill was talking, but also as it transitioned to Bob and Ralph. So they're related to kind of this idea of liability. So I don't know if anybody would like to answer, anyone can, but I mean, this is a question, I don't know if it's rhetorical, but wouldn't liability be greater if not using prevention through design? I think maybe that came in through Bill's. I don't know if you can react to that or if there's anything that strikes you about that, or
Chris, who are you asking?
I was wondering if you had any reaction to that one on liability, since it was brought up so much during the research that you did.
Yeah, it's a great question because once we started seeing it, we started looking for material that said someone has researched this question. And we so far haven't really found anything one way or the other that says, yes, there are more cases decided against firms that don't do this kind of planning or that have done it. And so if someone knows that, we would love to see it because we hear it a lot. Our colleague Rick Reinhardt has done a lot of work on PTD, and when he and I have talked, he's mentioned that that's something he's heard too. But when we try to pin it down, we're struggling to find that.
Thank you.
If I could comment on that.
Yes,
just
please.
a couple thoughts I had. One is there's definitely a lot of liability with a fatality. We're talking about falls today. There's a lot of falls every year in the construction industry. And when you have a fall, there's a lot of liability there. A lot of these small contractors, if they have a fall, they end up just closing up shop. I mean, they go out of business. The other thing is, when Jose was presenting on the resources, the report by Gambatees, there's a nice section in there that talks about liability. They actually developed some contract language that can be used to try to help with liability issues. And I've sat in some training with Skanska where they address that as well through Jason Timmerman when he was the health and safety director at Skanska a number of years ago.
Great, thank you, Scott. This one was, I think, aimed at Bob. It came in during your talk. Are the HSC identification or HSC ID plans is what was written, done for all projects? Is there a dollar amount when plans are mandatory?
That's actually a great question. What we do is we do the hazard plans for all the large projects. Jacobs has a lot of large projects, but we also have a lot of smaller or medium-sized type projects. Typically, we have a checklist that we develop so we can do it quicker. So a lot of times you don't really want to go through a large formal process for a smaller project. It just doesn't need that level of detail. So we use a checklist. So I hope that answered that question.
I think it does. And just to follow on to Ralph, the question on the modular stairs, this should be a simple one. Were those temporary stairs or permanent parts of the finished design structure?
Those were permanent stairs that would be part of the final construction. It was all about sequencing and trying to get them on site as soon as possible.
Great. This one is aimed at Scott. What efforts are in motion to get PTD more traction in building codes and other regulations that would shape the work of architects and engineers?
Or so there's a number of things that we're doing that I think could potentially relate to this. Although I definitely feel that there's a lot more work that needs to be done. But again, there's the consensus standards that were developed. Jose talked about that. The ASSP 810 0, ASSP Z590. Also, there's a technical report from the ANSI A10 committee that was published several years ago. The Arizona State workshops, I think, are something that we're doing now that relates to this to a certain extent. And we're in discussions with AIA about some of these issues as well. But it's certainly something that continues to need to be addressed and worked on.
Great, thank you, Scott. This one came in during, I think, the OSHA discussion. So it's for you, OSHA. Can a parapet wall be, or it is for you. Can a parapet wall be 39 inches to meet OSHA's guardrail height of 42 inches plus or minus 3 inches?
The answer to that is yes. Yeah, we have that tolerance there. So both subpart M and D allow for that plus or minus 3 inches.
One of the things that's come up in some of the questions is about skylights. So one question was, when are skylights going to stop being put in buildings? But I'd also, like to hear what, Scott, you think of that. And TJ, you talked a little bit about skylights and the fact that we're not doing a great job in this country by installing strong skylights. So Scott, do you want to react to that first?
I mean, my general feeling on skylights, I think somebody said it earlier, maybe been TJ, that, it's just kind of sad that, NIOSH put out an alert 30 some years ago. There was like 8 different construction workers that fell through skylights and died. And yet it seems like every year the same thing is happening in this country. And yet a lot of other countries have much higher standards. You can get skylights that you literally can't fall through. They're designed to prevent that. And yet it continues to happen in this country. So there's very simple things like that need to get addressed to reduce the number of fatalities that we're seeing in our industry and injuries in our industry. That's my main view of it. It's really sad, and it's something that needs to be addressed and worked on more, unfortunately.
Yeah, let me add to that too. Right? It's unique in the U.S. A good example is the saw, the new table saw. It's been out for 10 years. And don't cut your fingers off, right? Perfect idea of prevention through design. And yet there's a huge lobbying organization that simple mechanism that saves your fingers not be put on saws across the United States. Actually, NPR had a very long story about it. There seems to be a reluctance in the U.S. to adopt things that we know work, going back to the anti-tube lock on cranes and stuff that Dave McCullum put together back in the 60s. It's probably an American-based problem, but most things are fixed, in my opinion, by litigation than legislation.
All right, thank you. This one I think is for Bob and or Ralph. For Bob's HSE and design plan, does he use a checklist for each step of the process broken down by responsibility?
Yeah, so what we do is we typically have different levels of review that we do for the different types of stages that we're at within the project, going from feasibility, conceptual, BOD, detailed design. So we have various reviews that we do within each one of those sections, and they're very weighted towards actual meeting of SMEs or subject matter experts with a very large job. And then for the smaller jobs, it's more of a checklist type oriented way that we progress through that. So that's how we do it.
Great. A comment's just come in from one of the folks in attendance about an additional resource from AIHA developed by Dr. Popoff with NIOSH support, assisting OSHA professionals make the business case for PTD. And I think we saw on the slides that Jose was presenting that he was the recipient of one of the recent NIOSH PTD awards. So that's great information. This one I was kind of going to take this came in and said it appears that the panelists are advocating that the implementation and push for adoptions of PTD is the responsibility of the on-site safety officers. Is this accurate? I don't think that's necessarily accurate. I think what the panelists, in my view, have represented is being in favor of prevention through design to reduce construction worker death and harm. And I don't think there's any advocation that an on-site safety officer is responsible for prevention through design, while we've seen some examples of prevention through design approaches that can be done at the site level. This is really about pushing control of occupational health and safety hazards upstream, not at the job site. And it's upstream in the planning process. And that's where prevention through design belongs. So I'd say, no, it's not accurate based on the question. One question I wanted to go back to TJ on. I'm not sure I understand the question, but you might. It says, do you have a summary of this for a company to follow and help to create standards for a new construction manual?
Yeah, actually, great question. Thanks, Chris. I've been collecting, anybody on this call, if they email me, some of the practices I've been mentioning for 15, 20 years, and it's very up to date, including contractual language. So say you don't want ladders on your project, I have the language that you could put into a health and safety manual that the ladders last program would be in effect. So if somebody sends me an email, I'd be happy to share that with them, Chris.
Great. And if you'd like, either you or Jess can put your email in the chat, and I think it's on this block. I think we'll be distributing it to folks after the webinar. Looking at the time, I'm going to go ahead and not ask any. We've got lots more questions, but I think it's appropriate to wrap it up here. We've run through our allotted time and really appreciate the panelists who have joined us today. What you shared with us, it was interesting, informative, and incredibly timely as we're gearing up in our national campaign against falls for the next stand down that's coming up in May. Really excited to be talking, about prevention through design as part of our falls campaign, and appreciate the experts who've joined us to share your experience with us and with the participants in the webinar. So with that, I thank you, and I hope you have a great afternoon.
Take care. Thank you.
Thank you. Bye now.
Thanks.